Hi everyone. In this next example, we're going to take a look at multi-digit multiplication. This is actually the first in a two-part series. In this one, we'll take a look at the standard carry the one model, and in the next one, we'll take a look at the lattice model. As before, the purpose of this series is to look at those procedural approaches, to recognize that they do work and that they are a way of doing mathematics quickly, but to better understand that in order to use a procedural approach, we have to first understand the underlying mathematics behind it. And so this is to help you understand that mathematics so that you can help the students understand that mathematics. All right, so the first example we're going to take a look at is a common mathematical type of a problem, two-digit by two-digit multiplication. In this case, 32 times 24. And if you're like me, who went to school in the 80s, yes, I'm that old, you'll be familiar with the model where basically you'd start on the right-hand side. You would multiply the 4 times the 2 in this case, the two right-hand digits. And in that case gives us an 8. Then you'd multiply the 3 times the 4, which gives me a 12. If the 8 had a carry in it, I would add that carried number to this at this point. I would then multiply the 2 times the 2, but I'd also add this little mystery 0 at the end as a placeholder so that I can make sure that my place values are in the right spot. And of course, the 2 times the 3. And that gives me two numbers, which I can then add together to come up with a final answer of 768. Now, does this work? Yes. Does it work every time, as long as I don't make any mistakes? Does it have any mathematical understanding within it? It depends. If I'm taught procedurally, in other words, these are the steps you follow, then no, it doesn't have any mathematical understanding in it. However, if I'm taught conceptually and I have an understanding of why those steps happen, then I can actually answer the questions of how does it work? Does it work every time? And most importantly, how can I connect this strategy to what I've been doing in previous grades? Well, maybe a concrete example might help. So let's pull out our base 10 blocks. So what I'm going to do when I'm doing multiplication of these big numbers is really I'm just going to think of them as an array, because the array model or area model really is a very concrete way of looking at this at these numbers. So I'm going to build an array that's 24 units high and an array that's 32 units long. However, because I'm using base 10 blocks, I'm going to use the 10s to represent the 2010 or the 20s, and I'm going to use the units to represent the 4. Likewise, I'm going to use the 10s to represent the 10 place, so the 30, and I'm going to use the units to represent the 2. All right, well, let's start multiplying this area out. First of all, if I've got a bunch of blocks that are 2 10s high and 3 10s long, well, that gives me a 10 by a 10 gives me 100. This 10 by this 10 gives me another 100. This 10 by this 10 gives me another 100, so on and so forth, so that I end up with 600 blocks. All right, let's do the 4s and the 30s. So each of the 30s is 30 units long by 4 high, so 3 10s long by 4 1s high, and you can see I've done those with the sticks. Likewise, the 20 times the 2 is 2 10s tall and 2 units wide. And then the 4 and the 2, or 4 times the 2, will give me 2 units wide and 1, 2, 3, 4 units tall. All right, so I've filled out the area, and I can very easily start counting those blocks. So I've got the 20 times 30 gives me 20 rows of 30. I can also just look at this as 1, 2, 3, 4, 5, 600 blocks. and that's 600. 4 rows of 30 is 120. I can also do that by saying that I have 12 tens. 2 rows of 20, which works out to be 4 tens, is 40. And 2 columns of 4 is 8. Or I can just count the units: 1, 2, 3, 4, 5, 6, 7, 8. All right, so that does tell me that if I just add the numbers together, that 600 plus 40 plus 120 plus 8 works out to be 768. It's a nice visual way of looking at this, but let's see if it actually matches with what we've been doing with the standard model. And maybe I might even get you to pause the video here to take a look at these two models and to see if you can see the connections. All right, let's see if you have. Well, first of all, let's see the 128 here is simply these guys added together. It's what happens when you multiply the 4 times 32, which is essentially what we did in this first step. How about the 640, which is what you get when you do the 20 times the 32, is 640. Now, what this is actually doing, and here's where the underlying math lives, is this is using what's called the distributive property. And this basically states that when you take your multiplicand, so your 32 or your 24, and split it into pieces, so for example 30 plus 2 and 20 plus 4, you're not really changing the overall product. In other words, if we take all of our components, so everything in this quadrant, everything in this quadrant, everything in this quadrant, everything in this quadrant, we can treat each of those differently without changing the final answer. In other words, we're going to take each piece of the first multiplicand and multiply it by each piece of the bottom. That's how we get 4 of these. Let's take a look. So instead of 32, I'm going to represent that as 30 plus 2. Instead of 24, I'm going to represent this as 20 plus 4. And the trick with the distributive property is that basically every piece of this sum, every addend, has to multiply with every addend in this one. So we end up with a 4 times a 2, these two, which gives us the 8. We also have the 4 times the 30, so 4 times this 30. We have the 20 times the 2, which gives us this 40, and then the 20 times the 30, which gives us these 600. So really, if we add all of those pieces together, that gives us our answer of 768. And of course, you see that all we've done over here is we've just taken a little bit of a shortcut, and we've solved the 120 plus the 8 as a unit, and we've solved the 40 plus the 600 as a unit. The 0 is only here because we're not multiplying 2 times 32. We're actually multiplying 20 times 32, and that's why we have that 640. Now, of course, this does have to fit in with other pieces, and it's actually an important concept to get your head around, because we do have to have a sense of the array model, because that helps us to work out, for example, factoring. In this case, I could say I've got 14 blocks, and so the question might be, is 4 a factor of 14? Well, you start counting out 1, 2, 3, 4, 2, 2, 3, 4, 3, 2, 3, 4. But we still have those 2 extra, so no, it's not a factor. We can work with fractions. We can work with equivalent fractions. For example, this might include that 1/2 is the same as 6 out of 12 in this case. If I drop off that bottom row, it might be 4 out of 8. If I just keep the top row, it could be 2 out of 4. If you go into high school, we actually start moving to algebra tiles, which use that area model as well. So as I mentioned, in the next video, we'll take a look at the lattice method and see how this model relates to that.